User interfaces, or UI, are used in virtually every real-time application that exists, from modern video games like Final Fantasy Remake and Call of Duty to corporate applications such as car configurators and visualization tools. Here you can see a couple of examples of video games and the on-screen HUDs and settings menus that players use while playing. Here's a Final Fantasy settings menu, the Final Fantasy on-screen HUD, the Modern Warfare settings menu, and of course the Fortnite main menu. In Unreal, UI is created using the widget editor. Everything from designing the look of your UI to programming what they do is handled in the widget editor. In this course, you'll follow along with me as I take you through an overview of the widget editor. We'll discuss the designer mode where you can design and lay out your UI, the graph editor mode where you'll program your UI, and the most common widgets that come with Unreal. I'll also share some tips and tricks for making the most out of widgets and how to avoid some common pitfalls. From there, we'll create a fully functioning survival game. You'll walk with me from start to finish, creating functioning menus, pickups, and the programming behind them. In the end, we'll have a playable survival game with a main menu, a settings menu, and a playable main level. You need to be at least a little familiar with the Unreal Engine, as we won't be discussing very basic topics such as how to download and install the editor or how to navigate within Unreal. But you don't need to know any programming or anything like that. So why don't you join me as we learn to utilize the Unreal widget system? There are a couple of things to be aware of to make the most of this course. First of all, please make sure you download the project files that are included. These files will have everything that you need to walk through the course. There are several meshes, textures, and particle systems included that you can use when building the various elements covered. Everything you need to create the survival game is included in the survival game folder. It also pulls from both the third-person example template and the shooter game example project available from Epic Games. Each of these are in their respective folders. I would highly suggest downloading each of these projects separately from the Epic Games launcher and spending some time going through them and figuring out how they were built. It is incredibly useful to understand Unreal. Also included are some example widgets to show how to set up the widgets that we're going to cover in this course. They can be used as a reference for how each widget works. They are available in the Unreal Widgets folder. Finally, please make sure you understand a concept fully before moving forward. There's nothing stopping you from watching a section over again to guarantee that you understand it. It will help you in the long run if the concepts make sense before you move on. So, what is a widget? Well, before I answer that question, I need to start with something else. UMG, or Unreal Motion Graphics. UMG is the entire system that envelops the current UI workflow in Unreal. It handles the back end for all of the visuals, the programming behind it, and the editor to utilize all of the tools. Before UMG, there was only Slate. Now, Slate is a very powerful system in its own right, but it's not particularly approachable. Slate can only be created in C++, and it isn't incredibly intuitive to use. UMG, however, can be created visually in Editor and programmed with blueprints. At the UMG core are widgets. A widget is a special type of blueprint with predefined functions that can be used to create a user interface. Widgets include a visual designer called Designer Mode, which can be used to visualize and lay out the look of a UI. Included are most UI elements that you will need, such as buttons, text, images, sliders, and panels. Widgets also include a graph editor, which is used to program the UI. For instance, what happens when a button is clicked, or when a user slides a slider bar. It's important to learn how to use widgets as they are the backbone for UI creation within the Unreal Engine. So with that, let's get started. The first thing we need to learn when working with widgets is how to create one. So, to create a widget, right-click in the content browser, go down to User Interface, and choose Widget Blueprint. Choose the user widget type and rename it. Another way is to go to Add Import, User Interface, Widget Blueprint. This is the primary asset you'll be working with when creating UI. It contains all of the functionality and UI elements we will need. There are a There are a couple of things that need to be done in order to display a widget in the viewport. Let's go to the level blueprint. You can get there in the main editor at the top menu bar. Now, what we need to do is pull off a pin from Begin Play and type Create Widget. You can see that this adds a Create Widget node. If we click on Class, we see a list of all of the available widgets in the project. Let's choose This is an example widget. Next, let's create a variable for the widget in case we want to do anything with it later. You can do that by pulling off a wire from the Create Widget node and choosing Promote to Variable. We want to give it a name, so I'll call it Example Widget. Finally, although we have created the widget, we haven't yet added it to the viewport. So let's pull off a pin from our newly created variable and type in Add to Viewport. This will display the widget on the viewport. Remember to compile your blueprint. Now if we go back to the main editor and click play, we can see the widget in the viewport. It is worth noting that you can create a widget from any actor that exists within the level, not just the level blueprint. So you could put it in your pawn, your player controller, or a custom actor. So we've learned how to add a widget to the viewport, but what if we want to remove the widget from the viewport? Let's go back to our level blueprint. First, let's set up the blueprint to allow player input. Go to Class Defaults, Auto Receive Input, Player 0. Next, let's add an input for the R key. Right-click in the graph, type in Input R, and choose R Input. It should look like this. Let's grab our widget variable and get it. Drag off from the variable pin and type in Remove from Parent. Choose this node and connect it to the pressed execution pin of the R input. Now when we press the R key, the widget should be removed from the viewport. Let's compile our blueprint and test it out. You can see that the widget shows up on the screen. Now if we press the R key, it removes the widget from the viewport. There are several windows in the widget editor that you need to be aware of. First, we will be going over the Designer Mode window. The Designer Mode is where you'll be spending your time designing the look of your widget. Here you can add and manipulate various UI elements such as buttons, images, and text, create animations, and assign events to your UI elements. There are several sections you need to be aware of when using the Designer Mode. The top menu bar is where you will find some general buttons for using the widget editor. Just like regular blueprints, you must compile a widget blueprint for changes to take effect. You also have a Save button, a Browse button, which takes you to where the widget is located in the content browser, some debug components, which we will go over later, and the Play button, which will allow you to play the level right from the widget editor. Also on the top right, you have the two modes you can switch between, the Designer Mode and the Graph Editor mode. The viewport shows what your current widget will look like. The dotted line rectangle is what will be rendered on the viewport when your widget is created. Everything outside of the lines will not be rendered in the viewport. You can change the size and aspect ratio of the window by clicking and dragging the double arrow around on the screen. You can see that when you click the double arrow, several common window sizes show up for reference. Now I want to mention that this rectangle is for reference only. If your screen size doesn't match the size of this rectangle, you may have problems viewing your widgets. You also have your zoom factor, which changes as you zoom in and out of the widget, and pixel position. Then you have your current screen information for the widget and your DPI scale. In the top right, you can set various viewing options such as the dotted line visibility, widget locking, position snapping, and your screen size. The screen size is important because it will allow you to view your widget in the correct size and aspect ratio. So for instance, if you're building your application to PC, the aspect ratio may be different than if you're building to an iPad. There are multiple common sizes for everything from a tablet, to a phone, to a monitor or TV. The palette panel contains all instances of UI elements that can be used, such as buttons, images, and text. There are multiple groups to choose from, and the default widget types can be used to make most UI elements for a game or application. We will discuss more in detail some of the more common UI elements available later in this section. The Hierarchy panel contains all of the UI elements currently contained in your widget. This will include buttons, images, text, scroll menus, and any other item. The items contained in your widget are nested in layers, similar to Photoshop layers. Layers appear more in front in descending order, so a lower element will sit on top of a higher element. Some elements can only contain a certain number of child elements, such as a border or a button. Others can contain as many child elements as you want, such as a canvas or a horizontal box. The Animations panel contains all animations in your widget. You can create all kinds of animations to make your widgets more dynamic. You can animate most of the primary properties for each UI element. To the right of the Animations panel is the Timeline panel, where you will create animation tracks for your various widget animations. You can create and set keyframes, add or remove tracks, and view your animation tracks in the widget window. Please note that 427 has separate panels for the Animation and Timeline panels. We will go over animations in more detail later in this course. The Details panel contains all information about your currently selected UI element. This is where you can change things like size, color, and alignment, and also where you will create and assign events for buttons and inputs. There are many various UI elements that come pre-built with Unreal. Most of what you need to create UI for a game or application is available with the standard Unreal UI elements. This section of the course will be used to go over some of the more common elements that can be used to create UI. As you can see, there are many sections to choose from and many elements in each section. If you are unsure of what an element does, you can roll over the element and get a short tooltip to help you utilize it properly. A border element is used to encapsulate a single child widget in order to surround it with a background image with padding. The amount of padding can be adjusted by clicking on the child widget and changing the padding amount. The background image can be changed by going to Appearance, Brush, and selecting an image from the drop-down. The color of the image can be adjusted by changing the brush color. You don't have to attach an image. If you want the border to be a solid color, just leave the image blank and change the brush color. A button is an object that completes a particular action when clicked. You can change the appearance of the button by going to the Appearance tab, then Style. There are several options for changing the look of the button. The normal, hovered, pressed, and disabled sections manipulate the appearance of the button and when it is hovered, pressed, or disabled. You can add a custom image, change the tint of the image, and draw as a specific type of image, such as a box, rounded corner, or just the image only. You can also change the overall color of the button by adjusting the background color and opacity. You can assign events by clicking on the plus buttons at the bottom of the Details panel. The on-pressed event fires when the mouse clicks on the button. On-clicked and on-released fires when the mouse button is released. And on-hovered and on-unhovered fire when the mouse hovers or stops hovering over the button. If we add the on-clicked event, it will take us to the graph editor, where we can add logic that happens when the button is clicked. A checkbox provides the player with a true or false input. Checked is true, unchecked is false. This option is great for settings that only have an on-off functionality. You can initialize the checked state under Appearance, Checked State. You can change the look of the checkbox under Style. You have the ability to use either a standard checkbox or a toggle. Similar to a button, you can customize the look of the checkbox by changing the style sections. The checked and unchecked looks are simply images, so you can add your own that you have created. You can also add a sound effect when you check, uncheck, and hover. An image is a simple element which contains an image only. It is great for menu backgrounds and title sections. You can customize the image by clicking Appearance, Brush. Just like with a button, you can choose a custom image, the image tint, and how you want it to be drawn as. You can also customize the overall color and opacity by changing the color and opacity. You can use a progress bar for load screens, health indicators, settings, or anything else that needs a bar that can fill up. You can change the background image, fill image, and marquee image under the style. Under progress, the percent variable determines the total amount that the slider bar has filled. The values go from 0 to 1, so 0 is 0% and 1 is 100%. Bar fill type allows you to toggle which type of fill you want. You can choose a direction such as left to right, bottom to top, or you can have it fill from the center. The isMarquee toggle is a boolean that affects whether the marquee is shown or not. You might use this if the app is waiting to load but hasn't started loading yet, or if the bar is waiting for user input before starting. Fill color and opacity determines the overall color and opacity of the fill bar itself. A radial slider is a slider that users can manipulate that follows a circular shape. It will output a value based on the slider position. The value variable is the number that will output when you move the slider around and will affect the position of the slider hand. There are several variables you can change to affect the appearance of the slider. The slider range affects the overall range of the slider. You can set these to any two numbers, and the slider will get the number that the slider value corresponds to between these two values. The slider handle start and end angles affect where the slider radius starts and ends. The angular offset offsets a circle in a clockwise direction. The Show Slider Hand tick box will add a slider hand similar to a clock hand. If this is enabled, you can use the hand start-end ratio to affect the hand shape. You can also change the slider bar and progress bar color by setting the color of these two boxes. Under Style, you can change the images used with the slider and the bar thickness. A rich text block provides the opportunity to create more customized text within a text block. With a standard text block, you are limited to making changes to the text as a whole. But with a rich text block, you have the ability to manipulate any of the text within the block as you see fit. It is, however, slightly more complicated and requires some initial setup before using. To make changes to the rich text block, you will need to create a rich text data table in the content browser, which will allow you to create various new styles to use within a rich text block. To create this, go to your content browser, right-click and go to Miscellaneous, Data Table. The row structure will be a rich text style row. Let's give it a name, Rich Text Data Table Example. Now double-click on the data table. For every new style, you will need to add a data row. We will start by adding a default data row. Now this looks very complicated, but it's really not. It's just a set of variables that can be adjusted. Right-click on the name and rename it to default. This name will be the name that we refer to when programming the rich text block to use the various styles. Under Details, we can change the font, font size, font color, and many other options. For now, we will use the Arial font with a font size of 12 and a color of black. Next, let's create a header version. Click the Add button again to create a new row. Right-click on the new row name and rename it to Header. Under Details, change the font type to Arial Bold and the font size to 20. Then change the color to black. Now that we have a rich text data table set up, we can use it in our widget. Create a new rich text block. Set the size to 500 by 250. Under Appearance, Text Style Set, choose our new data table. Now we can add our text. You may need to compile to see the results. We can see our text, but it's all one style, the default style. So how do we add our header style? There's a tag we must use to change styles for the rich text block. Click on the text again and add a tag like so. You have to put the style name within an open and closed angle bracket. This tells Unreal to start using this particular style. To tell Unreal to stop using this style, put a / in between an open and closed angle bracket. The style change starts with the name and must end with the open and closed angle bracket with a slash in between. You can add as many styles as you want within a rich text block. You just need to create a new row in the data table for each style. It's important to note that styles can only consist of variations to the text itself. It will not affect things like alignment or justification. To change these, you will need to create a new rich text block. A slider, as the name suggests, is a slider that will output a value between a specifically defined range. It's just like a radial slider, only it moves left to right instead of in a circle. The value is the currently selected value of the slider and will be the number output when the value is changed. This number also affects where the handle is located. The min and max value are the largest and highest numbers that the slider can reach. As with the radial slider, the slider will automatically output the value between these two numbers based on the slider location. Orientation will allow you to change between a horizontal and a vertical slider. You can change the slider bar and handle overall color and opacity here. You can also choose whether the handle will be indented or not. Under Style, you can customize the image used for the background and handle, as well as the overall bar thickness. A text block is a simple text block that can be added to a widget. It is a much simpler version of the rich text block that can only contain one text style. The text section is the actual text which will appear in the block. You can customize the look of the text under the Appearance tab. Overall color and opacity can be changed with the Color and Opacity picker. The font and font appearance can be changed under the Font section. New fonts will need to be added as new assets. To do so, go to the Content browser and either drag the font into the Content browser or use the Import button. Unreal will create a new font asset for the font, which will make it available for use within the text block. Note that fonts with multiple styles will create a new font asset for each available style. Now in the Font section of the widget, you can choose the new font under Font Family. You can also change the typeface, the size, and the letter spacing. Feel free to play around with the other sections here to change the overall look of your text. Justification is where you can change the justification between left, center, or right aligned. The Input section is where you will find most of the user input widget types. These can be used for a variety of purposes, such as capturing text and capturing an input from a drop-down menu. A combo box is a drop-down menu which can be populated by various options, which can then be chosen by the user at runtime. You can set all of the default options for the menu in the default options list. Click the plus button to add a new element and give it a name. You can add as many elements as you like to the list and they will show up in the drop-down box. The selected option is the currently selected item. In this example, we can add default as the current selection. You can change the maximum list height, which determines how many items will show on the screen at a time. You can also select whether the drop-down menu has an arrow caret. Under Style, you can customize the appearance of the menu by adding images to the background and menu itself and changing the font style. Here you can add sounds that play when you press the menu or select a new item. There's also a key combo box type, but it is much more complicated to use and will not be covered in this course. The Editable Text widget allows a user to type a string of text on the keyboard and captures the input. It is very useful for inputting a player name, as a search bar, for custom save names, username and password, or any other item where you want a user to input a custom string. Under Content, you can set the starting text as well as the hint text. The hint text will show when nothing is input into the widget and tells the user what to do. Under Appearance, you can change the font, the color and opacity, the background image, and the caret image. You can also set whether it is a password, which will therefore only show dots when keys are captured. The The editable text multi-line widget is the same as the standard editable text, except that it will wrap the text to a new line. It can be used in the same way and also outputs a string. A spin box allows the user to press and move the mouse to set a float value. It works similar to a slider bar, but shows the value as well. Under Content, the value is the currently selected value that will output and will affect the slider bar location and the number that is displayed. Minimum and maximum value are the smallest and largest number that a user will be allowed to input. Minimum and maximum slider value are the clipping values for the slider bar itself. It will start and stop at these two set values, even if a user can go beyond that amount. Under Appearance, you can customize the various images for the background, slider bar, and arrows. Scroll down and you will see customization for the slider itself, where you can change the minimum and maximum amounts of digits displayed after the decimal point, snapping, and whether to use the slider or not. Under Display, you can change the font style, size, and justification. A text box is basically an editable text box with more options. Namely, you have a background image with padding, more font options, and a scroll bar. A text box multi-line is the same as a standard text box, but the text will wrap to the next line instead of scrolling. As you can see, there are pretty much the exact same options as a standard text box. Both will output a string when the user changes the text. An expandable area is a simple image that can be switched from one image to another with a click. You can customize the look of the widget in the Style section. As you can see, there are two images that are swapped between when the widget is clicked on. The border is an overlay image for the top border of the widget. You can customize the border color with the border color option. You may need to compile to see the results. There are a few more options under expansion. The Boolean is expanded decides whether the collapsed or expanded image is visible. You can also set the maximum height and the padding. A circular throbber is an auto-animated set of textures which rotate around in a circle. It's what you might see on a loading screen or when the game is saving. Under Appearance, you can customize the number of images rotating from 1 to 25. You can change the period, which is the speed of the animation. Lower numbers are faster speed and higher numbers are slower speed. A period of 1 means that the throbber will do one full rotation in 1 second. A period of 2 means that the throbber will do one full rotation in 2 seconds, and so on. To use the radius toggle, you must set the size to content to checked. Then you can set a specific radius instead of specifying the size. Under Image, you can customize the image that is rotating. A spacer is a blank widget that is used to put space between widgets. It can be very useful when using certain panel types, such as a horizontal or vertical panel box. The only variable you can adjust on a spacer is its size. Similar to a circular throbber, a standard throbber is an auto-animated set of textures which animate from left to right. Under Appearance, you can set the number of images from 1 to 25. You also have a few variables to change the appearance of the animation. If checked, Animate horizontally and vertically will animate the scale in each direction. If unchecked, they will not animate in that direction. Animate opacity is whether or not it animates the opacity of the image. You can customize the appearance of the image in the Image section. There's only one type of special effect, and that is the background blur. Background blur is a special effect widget that will blur everything behind it. This includes UI and the world itself. The primary variable for this widget is under Appearance, Blur Strength. This variable will affect how much blur to apply. Panels are special blank widgets that work as containers for other widgets. Each panel has special properties that allow for specific sorting of the widgets inside. You affect options for panels in the slot section of the panel's child widgets. Everything in the hierarchy will have a slot section, except for the topmost object in the hierarchy. Each slot type has different options depending on what type of parent the child has. Slots are very important on widgets because they define things such as the widget's position, size, alignment, Z-order, and anchor position. A canvas panel is the simplest container. If you create a canvas, you can set the size and position of the canvas, and then utilize the alignment of the canvas panel to set other widgets in certain positions inside. It is great for grouping elements for certain sections of menus, or for sectioning off specific parts of the screen where menus will reside. In the slot section, you can change the anchor point of the child widget. You can see that there are lots of options where the anchor can be located. You can also customize the position of the anchor point. Depending on the anchor point you are using, you also have options below for position and size, or offset if you are using a fill anchor point. You also have the alignment, which the anchor point will affect, or you can customize the position. Size to content will automatically set the size based on the size of the content of the widget. This is very useful for centering text. Z-order can be very important in certain widgets. The Z-order determines where a widget appears in relation to other widgets. For instance, if we have two images overlapping, one red and one blue, you can see that one sits on top of the other. If we want to change this, we can change the order in the hierarchy. But let's say we don't want to change the position in the hierarchy. Well, then we can use the Z-order to change its appearance placement. If I set the bottom image Z-order to 1, you can see that it now appears on top. But then if I set the other image's Z-order to 2, now it appears on top. The Z-order is a tool that really gives you fine control over exact placement on the appearance order. One more thing about the canvas panel, its biggest caveat is that it is not really dynamic. So it will not auto-scale or position elements without additional programming. This means that if you don't know the exact screen size and aspect ratio, the canvas will always risk not ending up where you want it, or worse, going off screen. A grid panel is similar to a canvas panel, but you can split it up into smaller sections again, each section controlled by a percentage of an area. Think of it like a table in Word. Each section is separate from each other and can contain any number of widgets. You have less control of the exact position as in a canvas panel, but it is somewhat more dynamic than a canvas panel. On the grid panel widget itself, you can set the number of columns and rows that you want by clicking the Add button. The float number here is somewhat confusing. Basically think of it like what percentage of the grid panel you want that column or row element to take up. So you want all of the column elements added together to equal 1, and all of the row elements added together to equal 1. So for instance, if we add 3 elements to the column section, there will be 3 columns. If we set the first to 0.2, the second to 0.6, and the third to 0.2, that is telling it that the first column will take up 20% of the grid panel, the second column will take up 60% of the grid panel, and the third column will take up 20% of the grid panel. 0.2 plus 0.6 plus 0.2 equals 1, 100%. When we add a widget to the grid panel, we can drag and drop it to the grid section where we want it to be. If we want to move it later, we can use the arrow buttons to move the child widget to the next row or column. Or under the slot section of the child widget, we can set the row and column number. We can also set horizontal and vertical alignment of the child widget. A horizontal box is used to automatically align its child widgets into a horizontal layout. If we drag an image into the horizontal box and then duplicate it, we can see that it automatically places it next to the previous image. There are no additional options in the horizontal box itself. The slot on the child widget contains several options. The size will determine whether it is automatic based on the image size, whereas the fill option will make it fill the rest of the area of the horizontal box. You can also customize the padding and the alignment. If we continue to duplicate the images, you can see that it continues past the edge of the horizontal box. so this needs to be kept in mind if designing a dynamic menu. A scale box is a container that will auto-scale all components it contains, keeping the desired aspect ratio. The scale box is great for creating custom UI designs that will be dynamic on a screen that you don't know the size or aspect ratio for. You can see that if we add an image to the scale box, as we move the dimensions of the scale box around, the aspect ratio of the image remains the same and scales according to the smallest dimension of the scale box. The scale box can only contain one widget, so to add more you'll have to create another panel type to act as the intermediary. You can see if we add a canvas panel to the scale box, we can now add multiple images to the canvas panel and lay out the design however we wish. The scale box will then keep the desired aspect ratio regardless of the screen size. There are several options for the scale box itself. Under stretching, you have multiple options for how it handles the scaling. Fill will not keep the aspect ratio, but rather act as an arbitrary scale for whatever is inside. Scale to fit is the default option and keeps the aspect ratio according to the smallest size of the scale box. Scale to fit X will scale according to the X direction and clip everything outside of the area. Scale to fit Y is the same but for the Y direction. Scale to fill will clip either in the X or Y direction if the scale box is not exactly the image size. You can even set a custom scale with or without clipping. Stretch direction will allow you to constrain if the children will only stretch up or down from its original size, or if it will stretch both up and down. In the child widget of the scale box, you can only manipulate the alignment. A scroll box works similar to the horizontal and vertical box, only rather than continuing the children past the edge of the widget, it clips the children widgets past the edge of the scroll box and allows you to scroll instead. There are several options that you can customize on the scroll box itself. You can set it to a horizontal or vertical orientation. You can set whether the scroll bar is visible or not. You can utilize the mouse scroll wheel to scroll. You can set the scroll bar thickness and padding. You can set several ticks for specific settings of the scroll bar, such as to always show the scroll bar, whether you want a user to be able to overscroll past the options, and whether to smoothly animate the scrolling with the mouse wheel. Navigation settings will affect how it will scroll. And you can allow a click and drag with the right mouse button to scroll the box. The child widget gives you alignment options and padding options. The size of the child widget will determine the size in the scroll box. It will snap to the orientation that you are using unless you change the alignment. As you can see, as you add more images to the scroll box, you can now scroll through them. A vertical box works exactly like a horizontal box, only in the vertical direction. Just like the horizontal box, there are no additional options in the vertical box itself. In the child widget, you can customize the padding, the size, and the alignment. There are some additional functionalities that are available for most widget types. They can be found below the Appearance and Style sections. Here is where you can change things such as the tooltip text, whether the widget is enabled or not, its visibility, and its render opacity. Visibility is an important section that can be kind of cryptic. There are 5 options that you can choose from. Visible means that the widget is visible on the screen and is what is called hit testable. Hit testable just means that the cursor or mouse can interact with the button. So for instance, if it is a button, the click, hovered, unhovered, pressed, and released events will fire when the mouse interacts with it. The next option is collapsed. What this means is that the widget is not visible in the viewport, it is not hit testable, and it does not take up any space in the viewport. So for instance, if you have several buttons in a horizontal box and you make the center button collapsed, not only will it be invisible, but it will take up no space, so the other buttons will slide over where this button was. Next is hidden. This means that the widget is not visible and not hit testable, but still takes up space in the viewport. So with our example of the horizontal box with several buttons, if we make the middle button hidden, You can see that it is no longer visible, but it still takes up space in the horizontal box. The other buttons do not slide over to fill in the gap. Now the last two are pretty much the same, but just affect either the widget itself or the widget and all of its children. Non-hit testable means that the widget is visible, but the mouse will not interact with it in any way. Now, you may be wondering why there is no option for hit testable but not visible. Well, this is actually pretty easy to set up. If we pull a button to the viewport and go to the Details panel under Appearance Style, we can set each of these images to draw as none. Now this button is hit testable but not visible on the viewport. The next section is the Render Transform. The Render Transform section works differently than the size and position slot at the top of the Details panel. Think of the top section as the absolute position and size of the widget itself, and the Render Transform as the offset for the widget when it is rendered. You can change the render position, scale, shear, angle, and pivot point. When you do, it offsets these parameters from the original button parameters. Events are also located below and are how you program what happens when you click a button, slide a slider, and any other functionality built into the widget. We will discuss this further in the Widget Blueprints section of this course. The last section that we're going to talk about is the User Created section. This is where all of the custom widgets that you've created will show up. You can actually use other widgets you've created inside of another widget. Now, why is this important? For one, you can create specific reusable widgets that you've created over and over again without rebuilding them. Then, if you need to make a change to that widget, you can just make one change to the parent widget, and it will trickle down and change all instances of this widget. Let's try it. Let's say that I want to make a custom button. I want multiple instances of this button that look relatively similar with only a minor change or two. Create a new widget in the content browser. Let's call it Button Instance. Double-click on it to open the editor. Now let's get a button and bring it into the hierarchy. Next, let's go to the Graph Editor. Grab the button from the Variables section and bring it into the graph. We want to get this button. Now pull off a wire from this node and type Get Style. Choose this option. Right-click on the style output and choose Split Struct Pin. This will show us all of the available variables for the struct. We're only interested in changing one variable of the struct, which is the tint for the style normal. So to do this, we need to pull off a wire from the style normal of the struct and type Set Members. Choose Set Members in Slate Brush. Click on the node and in the Details section, tick the Tint option. This will allow us to make changes to the tint of this variable. Pull off a wire from the new tint variable and type Make Slate Color. Right-click on the specified color and choose Split Struct Pin. Okay, so now we have the individual colors that we can affect for the tint. Let's create a random color for it. Right-click on the editor graph and type Random Range. We want to choose Random Float in Range. Keep the min value at 0 and change the max value to 1. Then connect it to the specified color R input of the Make Slate Brush node. Next, duplicate the Random Float in Range node 2 times. Connect each of these to the specified color G and specified color B inputs. Connect the execution pin to the Event Construct node. Okay, we're done here. Next, let's create another widget. We'll call it User Widget Example. Double-click on the new widget to open the editor. Let's put a canvas panel in just to have something to put our button inside of. If we go to the User Created section, we can now see that our new widget, Button Instance, is available. Drag this into our canvas, and you can see that our custom widget is a part of this new widget. You can see that every time I move the button, a new random color is created for the tint. Now let's duplicate the button. You can see that each instance has its own random button color. Let's make a few more instances of the button. You can see that each button has its own unique random color. Great! Now I've created just one button, but each instance is slightly different. Now we have a problem though because I forgot to add text to the button. We have 8 buttons here, so if I had to add text to each of them, it's going to take a while. Let's go back to the button instance widget. We can get there by clicking on one of the instances and clicking in the top right corner here where it says Edit Button Instance. If we go back to the designer, we can add a new text block on top of the button. Let's set the font size to 10. It looks small here, but it will look correct when we go back to the other widget. Now if we go back to the user widget example, we can see that a text block has been added to all of the buttons. The ability to instance user-created widgets makes the UMG system very powerful and gives you the ability to create dynamic menus and reuse widget assets in other projects. If you want a more detailed examination of how to utilize user-created widgets, I'll talk about this more in my Advanced Widgets course. We'll also be making a user-created widget and using it several times in the Creating a Survival Game section of this course. Now let's look more in depth at the Animations panel. To open the Animations panel, you can go to the bottom of the Designer Mode window and click on the Animations button. You can